Welcome back. Still on the law of indices. Now we shall be looking at the negative index law. The negative index law states that when a base is raised to a negative power, instead of having a raised to power of 2, we are given a raised to power of minus 2. Law of indices demands that this negative should be made a reciprocal. Now I bring back my a raised to power of 2. So anytime a base is raised to a negative power, it is expressed as the reciprocal of the base and its power. So if I have 2 raised to power of minus 3, I'm going to be having 1 over 2 raised to power of 3, which is 1 over 8. So hope you are still there. Anytime we have a base raised to power a negative raised to a negative power, this negative is simply the reciprocal of the base together with its power. But there is a special case of this. Anytime we have the base now occurs as a fraction, like 2 raised to power of 5, 2 over 5 raised to power of minus 3. When we have such, this negative, instead of going through the normal way of having 1 over 2 over 5 raised to power of 3, which we will arrive, but is going to be lengthy, I will teach us a simple tips on solving such. So anytime we have such, this negative automatically reciprocates the base. Instead of writing now 2 over 3, I shall be having 5 over 2. Why? Because of this negative sign. Then I bring back my raised to power 3. And this becomes 5 to the power of 3, 125, over 2 to the power of 3, 8. So anytime you have a fraction as your base raised to a negative power, the negative simply reciprocates the positions of the fraction, then you bring back your power. Hope you are still there. All right, we go to the next laws as I wipe off the board. The next law is very interesting and easy. The zero index law. This simply states that any factor or number raised to the power of 0 is 1. A raised to power of 0 is 1. 1000 raised to the power of 0 is 1. Any number in the universe raised to the power of 0, the answer is simply 1. Okay, we go to the next law, which is the power law. The power law states that when a base and its power are together raised to another power, the two powers will multiply themselves. Students always make mistake of saying a raised to power 2 plus x. No, you multiply, and that is a raised to power 2x. If I have 2 raised to power of 3, all raised to power of 2, I can't have the answer as 2 raised to power 3 plus 2 is wrong. I multiply, and that is 2 raised to power of 6. When a base and its power are together, or perhaps in a bracket, raised to another power, the two powers multiply themselves. All right, we move to the root law. The root law is also very easy, which states that if I have a number expressed as a power of 1 over 2, you simply express it at square root, that is 4. There is a law about this, which I will explain in fraction law. So if I have 25 raised to the power of half, it is simply square root of 25, which will give me what? 5. This will give me 4. So anytime a number or a base is raised to power a fraction 1 over 2 only, we just express as a square root, and that is why we call it root law. Then we go to the last but not the least, the fraction law. The fraction law. It is very similar to root law, but just that it is no longer 1 over 2. It's still a fraction. Like I will now be having 3 over 2 instead of 1 over 2. This is a fraction. Law of indices demands that in such case, there are 3 points that should be noted. The base should be expressed within the root. Take the base, put it within the root. Let the denominator serve as the root determinant. Let the numerator raise everything to a power. Let's simplify further. The base expressed within, the denominator determines, the numerator raises them to a power. And this is, what is the root of 4, or what number multiplies itself twice to give 4? It is 2 raised to power 3, and that is 8. Then if I have 81 raised to power of, let's say, 3 over 4, we shall be having the 81 put inside here, the root, the 4, the determinant, then raise everything to the power of the numerator. Remember, the base within, the denominator, the determinant, the power, the numerator expresses them to a power. So what number multiplies itself 4 times to give us 81? It is 3 raised to power 4 that will give us 81. So the answer to this is 3, all raised to the power of 3, and that is 27. So there are still other ways with which we can solve this before we take some class exercises. Of course, a student who visualizes this 81 directly as 3 raised to power 4, then bringing up her power 3 over 4, will still arrive at the same answer. Why? Because this has automatically landed her back to power law, which states that when a base and its power are together raised to another power, the 2 powers multiply themselves. And that is 3 raised to power 4 times 3 over 4. This automatically cancels this, and he or she is left with 3 raised to power of 3, which is what? 27. So with either this or this, you are very correct. We shall be taking 1 or 2 class exercises to know whether we've understood what we've been taught. I will be wiping off the board. Okay, let's take 1 class exercise, still from UTME. I have 81 raised to the power of 33 over 4, then minus, I have 27 raised to the power of 1 over 3, all divided by 3 times 2 raised to power of 3. Then in this case, I shall use any of the laws I want, any of the method I want. I can use root law. I can just raise to power. I can see that all of them can be, this can be expressed in base 3. So I can have 3 raised to power of 4, all raised to power of 3 over 4, minus 3 raised to power of 3, all raised to power of 1 over 3, divided by 3 raised to power 1 times 2 raised to power of 3. This 4 takes away this 4, so I arrive at 3 raised to power of 3 minus, take away this, I have 3 raised to power of 1, all divided by 3 raised to power of 1 times 2 raised to power of 3 is 8. So 3 raised to power of 3 is 27, take away 3, divided by 3 times 8. And 27 take away 3 is giving us 24, divided by 3 times 8. 3 here 1, 3 into 24 is 3. And 3 over 3 will give us 1. So the answer to 81 raised to power of 3 over 4, take away 27 raised to power of 1 over 3, divided by its denominator is equal to 1. I hope you understood that. Please, if you have any question, please put your question in your comments section. All right, we take 1 more example as I shall be wiping off the board. Okay, the last question we shall be taking says 0.008 to the power of minus 1 over 3 times 0.16 to the power of minus 3 over 2. Remember what we've said before? Of course, this is in decimal. We shall express it in fraction, which is going to be 8 over 123, which is 1000, raised to the power of minus 1 over 3, times the same thing here, 16 over 1200, raised to the power of minus 3 over 2. Of course, this, because of what we said, that when the base is a fraction and the power has a negative power, the negative automatically reciprocates this, and this becomes 1000 over 8, still raised to the power of 1 over 3, times 100 over 16, raised to the power of 3 over 2. Remember, we reciprocate the base and not the power. The negative here reciprocates the base and not the power, so that you don't write 2 over 3. Then this is the same thing as 10 raised to the power of 3 over 8 is 2 raised to power of 3, which I can express both of them as a single fraction. Now remember, it is still raised to the power of 1 over 3 times 1 over 3. Then times, this is the same as 10 raised to the power of 2 divided by, 16 is the same thing as 4 raised to the power of 2, which I can raise as a single power 2, still times 3 over 2. This 3 eliminates itself, so I arrive at 10 over 2. Then times, this 2 eliminates itself, I arrive at 10 raised to power of 3 divided by, which is 1000. 1000. 4 raised to power of 3 should be 4 times 4, 16. 16 times 4, 64. Then we can reduce to lowest term. 2 here 1, 2 here 5. And that will be giving us 5000 divided by 64. 8 can be used to reduce them. We shall have 8 into this 625 over 8, and that is our final answer. So please, this is our task. Do the task and leave your answer in the comment section. Please always remember to like, follow for more. Thank you.